Okay, practice test 4, number 5. A farmer has 5,000 acres of land on which he plants 4 crops: corn, wheat, soybeans, and pumpkin. It costs 35 per acre to grow corn, 50 per acre to grow wheat, 25 per acre to grow soybeans, and 40 per acre to grow pumpkin. His expenses for crops total $177,375. The acres of soybeans are double the acres of wheat. Due to shipping limitations, the farmer is only able to plant 700 acres of pumpkins. So first we need to represent this situation with a system of equations, clearly identifying our variables. And then we need to solve for the number of acres of corn that the farmer will end up planting. And since we only need to solve for one of the variables, Cramer's rule is a good approach to solving this system. We're solving for a number of acres, so that's what our variables are going to represent. I'll use, let's see, C for corn. That'll be acres of corn. W for acres of wheat. S for acres of soybeans. And P for acres of pumpkin. Now, general rule with systems of equations is that in order to be able to find a single solution for the entire system, the number of equations that you have has to match the number of variables. So since I have 4 variables in this situation, I need to have at least 4 equations in order to make sure to find a unique solution. Let's see, rereading the problem again. Here's one of my totals, total acres of land. And the variables by themselves represent the acres of land, so I don't need to use any multipliers in this rule. We just need to add all the acres together and set that equal to 5,000. Another total that we have is total expenses, and then we're given the individual expense for each type of crop. And so that will be our multipliers for this rule. We've got 35 for corn, 50 for wheat, 25 for soybeans, and 40 for pumpkin. And that will be our total expenses, $177,375. Then they give us a relationship to work with. It says the acres of soybeans, the soybeans are double the acres of wheat. So we take the acres of wheat and double them, and the result of that gives us the soybeans. Now, in order to put this rule into my system and have everything line up correctly, I need to go ahead and write this rule so that all the variables are on one side and constants are on the other. So I'm going to go ahead and subtract 2w from both sides. And now it's set up in a way where I can get everything vertically aligned with my system over here. So we've got S and minus 2w. We've got 0 C's for this rule and 0 P for this rule. And that will be equal to 0. And then we have one more equation that actually doesn't involve a whole lot of complication, because this very last relationship only involves pumpkins. So the amount of pumpkins will equal 700. And yes, if we wanted to at this point, we could go ahead and plug 700 back into each rule of our system, and then end up with a system that only had 3 variables instead of 4 variables. But I can go ahead and solve it the way that it's set up, so I'm not going to take the time to do that. Now that I have my system set up, I can go ahead and solve using Cramer's rule. And Cramer's rule involves a ratio of determinants. In the numerator of the ratio, we have the determinant of the coefficient matrix, with the variable of interest being replaced by the constants. So you'll have an entire column that's replaced by the constant values. And then in the denominator, we'll have the determinant of just the coefficient matrix. So I'm going to go ahead and set up the denominator first. So we'll have the determinant of the coefficient matrix. The determinant of, and my coefficients in the first row, we have 1, 1, 1, and 1. we have our second row of 35, 50, 25, and 40. Then we've got 0, -2, 1, and 0. And then a row of zeros except for the 1 at the end. Okay, and then in the numerator, we're going to have another determinant. We're going to have the same matrix except for the column that contains the variable we're solving for is going to get replaced by the constants on the other side of the equal sign. And so we're trying to solve for acres of corn, which means we need to replace our seed column. I have that set up to be the first column in my system. So instead of writing these numbers, I'm going to write the constant numbers in the first column. 5,000, 177,375, 0, and 700. And then the other three columns will remain the same. So we've got 1, 50, -2, 0, 1, 25, 1, and 0, and then 1, 40, 0, and 1. And this really takes longer to set up than it does to solve. But now that I have these two matrices set up, I need to go ahead and use my calculator, because we don't find determinants of matrices that are this big by hand, not in this class anyways. So I'm going to go ahead and pull up my calculator and clear out my home screen. Go to my matrix menu and go over to edit. I'm going to select the first matrix. This time I need it to be a 4 by 4. So I'll push 4, enter, 4, enter. And it goes off the screen, but as you enter your numbers, it will pan across like it's supposed to. So my first row, I've got 5,000, 1, 1, and 1. 5,000, 1, 1, and 1. And my second row, 177,375, 375. And then after that was 50, 25, and 40. 50, 25, and 40. Next row, 0, -2, 1, and 0. 0, -2, 1, and 0. And then my last row, 700, 0, 0, and 1. 700, 0, 0, and 1. Okay, so my numerator matrix is set up. Now I'm going to go back to the matrix menu again. Go over to edit. And actually, I think rather instead of putting that entire matrix again, I'll just find the two determinants separately. That way I don't have to do quite so much button pushing. So scratch that idea. Let me go back to my home screen and make sure that it's cleared out, and it is. I'll go back to the matrix menu and select the determinant option from the math menu. And then go to my matrix menu and choose matrix A and push enter. So there's my determinant for the numerator. Negative 18,125. Negative 18,125. That's for my numerator. Now I just need to figure out what goes in the denominator. And I could just go back into my calculator and edit the matrix that I put in, replacing just the first column with these numbers, 1, 35, 0, and 0. So I'll go to my matrix menu. I'll edit my first matrix. This now becomes a 1. The rest of that row will stay the same. This becomes a 35, I think I said. Yes, 35. And the rest will stay the same. That's a 0. And the rest will stay the same. And then this is a 0. And the rest will stay the same. Now I'll go back to my home screen, clear that out, and again go into the matrix menu, choose the determinant option, go to the matrix menu again, choose my first matrix and push enter. negative 5. Alright, negative 5. And so when I do that division, that gives me a result of 3,625 acres of corn. So that's how we can use Cramer's rule in order to solve for just one of the variables in a system of equations.